Let's take a look at how we can be integrating trigonometric expressions that are like this by making use of the list of trigonometric identities that are actually available to us in our formula sheet. Let's take a look at an example. Let's say this question over here, 1a. In 1a, we are supposed to integrate sine 2 theta, cosine 3 theta, d theta. Let's refer to what we have in our formula sheet. So on our formula sheet, if we were to look at the section on trigonometric identities, what we are going to try do is to spot an identity that is as similar to this expression as possible. And to me, that would definitely be here, sine A, cosine B. I'm going to focus on the first identity that we have there. And if I were to just recode that identity, rewriting A to be 2 theta, B to be 3 theta, this is what I will have. We will have a sine, rewriting A as 2 theta plus rewriting B as 3 theta. So this I will write it as 3 theta. This is going to be equal to sine 2 theta cosine 3 theta plus cosine 2 theta sine 3 theta. There's also another version, which is going to be sine 2 theta minus 3 theta, and this will be sine 2 theta cosine 3 theta minus cosine 2 theta, then sine 3 theta. I will call this equation A, and I'll call this equation B. And the aim is to try to re-express this by trying to add A and B together. So if I were to add A and B together, on the left-hand side, this we will have a sine 5 theta, and this we will have a sine minus theta. And on the right-hand side, when I add them together, this will be 2 sine 2 theta cosine 3 theta, and this will disappear. So now I can try to make this a subject, and that will be sine 2 theta cosine 3 theta. 2, let me divide it across, it becomes half. So half of sine 5 theta. Sine minus theta is the same as minus sine theta. So let me write it as minus sine theta. And this gives me an alternative way to express this. And if I can just replace this by my result here, it is going to be half then sine 5 theta minus sine theta d theta. And individually, they are now easy for us to integrate. There's another way that I can try to re-express this, and still making use of the first identity, but re-expressing what we have here into, let's say, cosine 3 theta, sine 2 theta instead. Okay, just switching this. So if I were to go for this version, rewriting using the very first one, and the reason is because now I am seeing this cosine A, sine B, okay, the second term that is on the right hand side. That's synchronized to this, which means that A is going to be replaced by 3 theta and B is going to be replaced by 2 theta. So if I were to go for this perspective, then we will have a sine 3 theta plus 2 theta. This is sine 3 theta cosine 2 theta plus cosine 3 theta, sine 2 theta. Okay, and this is what I'm going to try keep if I were to go for the same strategy. The other version will be sine 3 theta minus 2 theta. This is going to be sine 3 theta cosine 2 theta minus cosine 3 theta, sine 2 theta. Calling this equation A, calling this equation B. How can I combine A and B together so I can be keeping this? And that will be taking this time equation A minus away equation B. And on the left-hand side here, we will have a sine 5 theta minus away. This is going to be sine theta. It's equal to this minus this disappear. This minus minus become plus. So we have a 2 cosine 3 theta sine 2 theta on the right hand side. Now making this the subject, we will have cosine 3 theta, then sine 2 theta is equal to half of sine 5 theta minus sine theta. So replacing this by half sine 5 theta minus sine theta, we're actually getting back exactly the same thing. And now let's integrate this half. I'm going to just factorize it out. And for this, when I integrate sine 5 theta, it is going to be minus 1 over 5 cosine 5 theta. And when I integrate sine theta, it is going to be minus cosine theta. So minus minus become plus. So we have a plus cosine theta. And let's not forget about the plus c. So it will be half times this, gives me a half cosine theta. Half times this gives me a minus 1 over 10 cosine 5 theta, then plus c. Let's take a look at another example. And in this example, question number 3a, part 1, we are supposed to integrate cosine 3x cosine x. And what we're going to do again is to make use of what we have in our formula sheet. So in our formula sheet, going to the section on trigonometric identities, we want to try to look for an identities that can give me an expression that looks as similar to this as possible. And I would say that will be the second identity over here, cosine A, cosine B. And what I'm going to do is I'm going to replace A by 3x and I'm going to replace B by x. Quoting the second row's identity, that will be cosine, replacing A by 3x. So it will be 3x plus B, replacing it by x. It will be cosine 3x plus x. This is equal to cosine 3x cosine x minus sine 3x sine x. Then quoting the other version of the identities that is in the second row, it is going to be 3x minus x. And this is going to be cosine 3x cosine x plus sine 3x sine x. Calling this equation A, calling this equation B. How can I combine the two equations together? So I'm going to be left with a cosine 3x cosine x. And that, I guess, it will be adding the two equations together. So taking equation A plus equation B, on the left-hand side, we will have a cosine 4x plus, this is going to be cosine 2x. And on the right-hand side, this and this gives me a 2 cosine 3x cosine x. This plus this, they will disappear. So making cosine 3x cosine x the subject, cosine 3x cosine x is going to be equal to half of cosine 4x plus cosine 2x. And this is what I'm going to be making use of to re-express this, which will now be a half. Then cosine 4x plus cosine 2x dx. Factorizing out the half, we will just be integrating cosine 4x, which will be 1 over 4 sine 4x. Integrating this, it is going to be equal to 1 over 2 sine 2x. Let's not forget about the plus c, so my answer is going to be equal to 1 over 8 sine 4x plus 1 over 4 sine 2x, then plus c. One more example. Now let's take a look at 10b. In 10b, first part require us to integrate sine 4x cosine 6x. Okay, and to integrate this, let's refer again to our formula sheet, because in our formula sheet, we have a list of identities. And looking at this list of identities, we want to try spot an expression that is as similar to this as possible. And to me, that will be this, sine A cosine B. So I'm going to be making use of that identity, replacing A by 4x and B, I'll replace it by 6x. Recoding the first identity there, it is going to be sine replacing A by 4x. So this plus replacing B by 6x. So this is equal to sine 4x cosine 6x plus cosine 4x sine 6x. This will be my equation A. And writing down the other version of the first identity, it will be 4x minus 6x. This is going to be sine 4x cosine 6x minus cosine 4x sine 6x. This is B. And what I'm going to do is I'm going to try to combine them together so that I will be left with a sine 4x cosine 6x, which is this expression over here. And what I'm going to do is I'm going to take equation A plus equation B. On the left-hand side, we will have a sine 10x. Then after that, it is going to be plus sine. This is going to be minus 2x. And here we have a 2 times of sine 4x cosine 6x. This will disappear. Now making this the subject, sine 4x cosine 6x is going to be equal to half of this. So 2 dividing over half of, we have a sine 10x. Sine minus 2x is same as minus sine 2x. So now we have another way to re-express what we have here into now a half of sine 10x minus sine 2x dx. This is going to be equal to half. Let's factorize it out from the integration notation. And here we will have a minus 1 over 10 cosine 10x. Then minus 1 over 2 cosine 2x. Minus become plus, so plus 1 over 2 cosine 2x. Then plus c. This is minus 1 over 20 cosine 10x plus 1 over 4 cosine 2x plus c.